Welcome back everyone and welcome to today's class. Today we are going to talk about application inspection. We have touched a little bit on this subject before. So a firewall inspects the packets going through it. That means that it understands the protocol and it adds when, for example, this PC communicates through the firewall, even if it's using NOT or not using NOT. Every time it makes a connection through the firewall, it needs to add that connection to the connection table so that when the return packet comes back, it can go through the firewall, even though the outside network has level 0 and inside level 100. And that only works when the firewall inspects the packet. And you configure a service policy for what protocols to enable inspection for. And you can also configure some kind of parameters. So you can edit stuff in the headers of the packets and some other features as well. So if we were to, it's a 3-step process. First, we need to identify which packets we want to inspect. So let's do a real easy kind of inspection policy. Let's say we just want to inspect the protocol HTTP. So first we create an access list. So we match the traffic. Let's call this ACL HTTP. And we will match permit TCP any from anywhere to anywhere on port 80. That's what we want to check for. Okay, so we have the access list. Now we need to create a class which links to that access list. So we do class map, and let's call this C HTTP. So class HTTP. And what we do here is we match the access list ACL HTTP. And that's it. We can do more advanced class maps in different access lists and other stuff as well, in a sequential kind of way. But in this case, we will just match for all HTTP traffic. And when we have created the access list or any other means of targeting that traffic, and we had tied it together in a class map, now we're going to create our policy. So we do policy map, and we give it a name. Let's call it P HTTP. Like this, and we do class C HTTP. So when we stumble upon an HTTP packet, what shall we do? We should inspect HTTP. And we can also sometimes give arguments to that. We can specify an additional policy map that has options for the HTTP protocol. But in its easiest form, we just do like this. So our configuration looks like this. We check for the class C HTTP and we inspect the traffic. And if we check our class map, we just match for the access list. And the access list looks like this. Permit anything equal to port 80. Okay, so now we need to enable that policy, and we have a few options. We can tie it to an interface, or we can tie it globally. So in this case, I will tie it globally. Then we just do service policy, and the name of the policy, that's PHTTP. And here we put in other int and inside, for example, or we just do global, like this. So if we do sh service policy, then we see the details. We have a service policy PHTTP, which has one class, and that's HTTP traffic. And here we see some counters. So we can see how many packets have matched the policy, how many has been dropped, how many TCP packets that has been dropped and the connection has been reset. And here we also see how many packets that has been sent per second with a 5-minute counter. Okay, so that's the easiest form. Usually when you do a global policy, you don't target just one protocol, because you can only have one global policy. So you put in all the protocols that you want the firewall to handle. Basically, all the protocols that you want the firewall to let through from the inside to the outside. Usually, at least. Okay, but what if we want to do this a little different? What if we want to alter the HTTP and change parts of its headers or stuff like that? Well, then we create an additional policy just for that. And let's call that policy HTTP extra. And we just don't press enter here. We need to specify what protocol it handles, because all the different types of policies have different options, and that's based on what protocol. So what we do is we do policy map type inspect. It's an inspection policy. And what do we want to inspect? HTTP. And then policy map type inspect HTTP, and the name of the policy, policy HTTP extra, like this. And in here we can do parameters. So HTTP doesn't have a whole lot of different parameters. What we can do is we can set a maximum for the body. So if we send like a message body that is bigger than 500 bytes, we can drop the packet. We can also identify protocol violations. So if the server, for example, sends something that isn't in the protocol, then we can take an action. So we do protocol violation action, and then what do we want to do when that happens? We can just drop a log message. We can drop the connection. That basically means that we close down the connection in a safe manner. But we can also reset the connection. And then we just send a TCP reset packet and it drops it right away. Let's do that. And we could also handle the spoof server. Right, we can, so let's say we have web servers on the inside or the DMZ. Sometimes when a hacker tries to hack into a web server, the first thing it does is it checks what the version of the server software it's running, like Apache or something like that. We could change that in the server with the configuration file of Apache, but another way is we just type in something else. So instead of sending back Apache version 2.6, we can send something like either something very generic like this, but then the hacker knows that we have changed it, and maybe take other actions like identifying the TCP fingerprints or something like that. But what we can do is we can say like IIS 1.0. So then it thinks that it is a Microsoft IIS web server. Quite nifty feature. Okay, let's use those two. So our policy map type inspect HTTP looks like this. We have two parameters. We spoof the IIS server and we identify protocol violations and reset those connections. Now we need to add this to our policy. So this is how our policy looks right now. Let's, instead of just inspect HTTP, let's remove that. We do inspect HTTP and then we put the name of our inspection policy. And that was policy HTTP extra. So now we have a global policy, PHTTP, with a class for HTTP, and we inspect the HTTP protocol with this policy as the settings. So let's see if we can. Well, in here we can see the action that has been taken. If we have reset the connection or what we have done. Let's see if we can mimic this somehow. I'm not sure. What if maybe the Cisco router has HTTP enabled? 193.234.88.1 port 80. No, doesn't look like it. Let's enable it then. HTTP server. maybe this version doesn't have any web server. HTTP. No, it doesn't seem like it. But are we able to reach this one? Let's see. This is not right. No, we don't have that configured at the time, but that's how the configuration is done anyway. We can do it for DNS also. We could, for example, do something like when we have a local DNS server like this one, then we don't want these other clients on the network to use anything else other than our server, so we can control it and secure everything. But if we try to reach like Google.com, we might use Google's DNS server because they are authoritative for that domain. And we can do a very easy thing. We let the firewall check for the authoritative response in the DNS header. So that's basically when you are communicating with this with a DNS server that is in charge of that domain. So basically all the DNS servers other than ours. So how do we do this? First, we begin with an access list, just like before. So we create an access list, we can call it ACL DNS. And we permit UDP any equal port 53, which is DNS. So what we'll do is, let's see. Yes, we create a class first, just like before. Class DNS match access list. No, we need to add to that list. Access list ACL DNS external permit UDP any. We need to check the source. So this goes in this direction, then the port is 53. And when it comes in this direction, the port is probably still 53, but the source ought to be equal. No, I think that rule will get that. So class map C DNS match access list ACL DNS, like this, just like before. Then we create our policy map type inspect, and we can name it policy DNS extra, like before. Policy map type inspect. We need to put in the protocol as well, DNS. Okay, so what do we want to do here? In the parameters, no, not parameters, we want to match header flag, and here we have it. The AA flag is the authoritative answer. So that is the answer from these DNS servers that handles a specific domain. If we just filter out all the responses, those internal network hosts won't be able to use it. So match header flag AA. And what do we want to do when we find one of those? We want to drop the packet like this. So our policy map type inspect DNS looks like this one. And we can put a whole lot of different other parameters when inspecting DNS, but let's do this just for now. And we'll do a policy map p DNS class DNS match DNS inspect DNS with the policy DNS extra like this, and then we activate it. Let's do it on a port this time. So we'll put it on the outside port because the replies will come from that direction. So service map p DNS, and we'll put it on the interface outside. Service policy is the command, like this. So if we check the service policy on outside, we see that we have a policy named pDNS using the class CDNS, and we inspect DNS with a couple of extra options. Basically, we drop every authoritative answer. So now they can use this one. And we may want to create an exception. So when traffic comes to this server, it can still receive the packets, because this one needs to still talk to those authoritative servers, but the rest of the network shouldn't. Okay, that's some of it regarding the service policies. I can show you one more thing, something called TCP intercept. Let's say this server, we want to protect this server from denial of service attacks. So one very effective denial of service attack is the SYN flood. We send a lot of SYN packets, which is the first step in the three-way handshake of TCP. So when one do that, then this connection table on the server will fill up, and after a while it will go very slow, or perhaps no one more can connect to that server. So how can we avoid that? We need very much hardware power on the firewall to remove that risk entirely. But we can offload some of the load to the firewall from the server and perhaps save it a little bit. Okay, so what do we need first? We need an access list to find all the TCP traffic, right? So access list ACL TCP, extended permit TCP any. Very broad. And let's remove the global service policy. What did we call it? I think we called it P. HTTP global. Okay, so now it's gone. We still have the DNS one, but that won't conflict with us. Okay, so we have an access list. We need a class map as well. Let's call it CTCP. And we will just match access list ACL TCP. We could also do match protocol. No, not on this. On some versions you can do match protocol and then but I think we can just do match TCP here. No, match TCP port. Well, we can match specific TCP ports. So we could like do range and though everyone, but in this case it's better with doing it like this with ACL. We can also have multiple match statements, which we can do so they are everyone needs to match in order for the class to activate, or one of them would match in order to activate the class. So we can do really advanced stuff here. You can also have a lot of different classes tied to the policy map. Let's call this PTCP. We need the policy map type inspect first. And we'll inspect TCP and we'll call it policy TCP intercept. Like this. No, policy map type inspect TCP. Maybe we do it directly in the policy. Let's do it. Policy map PTCP intercept class TCP, and in here we can do inspect TCP. No, inspect set. That's the one, I think. Set connection. Here we are. So we can set con max. So if we do it like this, then we will not allow more connections than 750. After that, we just block. We can also do, which is more suitable in this case, we can set a maximum for embryonic connections. Embryonic connections is a TCP connection which is on the first step of the handshake. So a SYN has been sent, but we haven't received a SYN-ACK from the other end. So if we set this to 300, there won't be more than 300 simultaneous connections. We can set it even lower, 50, like this. Okay, so our policy looks like this. Policy map PTCP intercept class C TCP, all TCP traffic in all directions. We set the connection limit to 750, max embryonic connections 50. And then we just do service policy PTCP intercept global, like that. And here we can see we have more data than before. We see that we have a set directive, 750, and 50 for embryonic. And we can also see the current embryonic current connections and how many we have dropped. So basically you want to set up a global inspection policy with all the protocols that you want to use. You want to have UDP and perhaps ICMP and maybe FTP and HTTP, etc., etc. And then as a global step, you can also set these TCP related options. And there are more options as well. Just go into the policy map and press the question mark, and you can see a whole lot of different options. But if you set these embryonic connection limits, if you get a real big SYN flood against this firewall, and we want to drop a lot of SYN connections, then the hardware will run out on the firewall. So in most cases it's probably best to leave that off, because the server can probably handle that kind of traffic better than the firewall. And at least you won't crash the whole network, you'll just crash one server. Okay, that's application inspection. Thanks for watching, and thanks for today.